In the last video, we actually derived the moments equation based on what we have done all along for this particular piece or this thing over here, right? Something that deals with the yielding part of the bend of a bending beam, right? Let's continue. If you still remember, we say that the linear part over here and here is all the same. They are all equivalent. Their distance are all somewhat the same. Okay, and therefore instead of writing such a long chunk of 4 equations over here, alright, we can actually reduce them into two stuff. Alright, because as you can see, the minus a and minus c, alright, from here to here, and from a to c, which is from here to here, is the same stuff. Alright, it's exactly the same. So instead of writing the integral from minus a to minus c, what I can actually write as is just 2 times c a to c, or in other words, you can also write as 2 times minus c to minus a. Alright, it's the same thing because they covers the same range. Alright, and likewise for the linear part over here, you can also do the same. Alright, so instead of minus a to 0 and then 0 to a, which is from minus a to 0 and then 0 to a, I can actually write 2 times, alright, 2 times 0 to a, alright, because this portion over here, they're exactly the same. Okay, so it's just simply that. So therefore what I have is this equation over here now. Alright, and now how do we dissect dA? Okay, let's come back to this system again. Alright, this is our cube that we are doing. Alright, so I'll just zoom in now. If I were to zoom in, I'll have this particular piece of area. We call this the dA. Alright, so we can name this length over here as b, and we can also name this as dy, sorry. And why is it dy? It's because we have stated that this particular length is y. It's the distance from whatever point that you want to see to your neutral axis. So therefore, talking about y, you're talking about dy, is still something about the y, the distance to the neutral axis. Alright, so I have a dy over here. So b dy is simply your dA. Okay, so I can simply sub in my dA now, right? And therefore we have from dA to b dy. So far so good. Same thing from dA to b dy. Alright, just to take note that this sy is simply your stress. Alright, when your stress is equals to your sy, which is your yield strength, then it starts to yield. And it's exactly the same as what we have seen just now, right? At the ships over here. Alright, at this portion over here, it actually starts to yield, right? Start to deform. And some may actually comes out of this and create a bump to your beam, alright, something like this, so to speak. Alright, simply leave the stress as Ey over R. If you still remember, we have said that the Mi is equals to this one. Alright, this is the beam theory. Then you just simply rearrange Er, you just bring the Y up here, you re-represent your stress as Ey over R. Alright, so I'll just keep the stress over here as that first. And also to remind you that this is stress times area, this whole thing is force times the perpendicular distance, the y. Alright, at least you know that this whole equation, what I've been doing right now, is the moment equation. Alright, so we are still finding the moment now, okay? And so since this is dy, alright, you can simply bring this dy over here. You can also simply bring this dy over here. Alright, and this integration in terms of dy, so you can simply bring all the constant out of the picture. Alright, let's do it together. Okay, so 2 times the integration, I haven't yet, so we just simply factorize out my yield strength and my b first. Alright, so I have sy is a subscript only, b, alright, the whole thing's integrate y dy, alright, this is the 2, okay, plus, so this is also 2, and then I can factorize out my e over r and b, since this is y over here. Okay, if I were to factorize out, what I have is this thing over here. So the y over here and the y over here multiply together become y squared. I factorize out my b e over r, which is over here, and my b. Alright, so I didn't cheat your filling. Alright, same thing over here, you can just double check. Alright, and therefore if I were to integrate all this now, since it's in terms of y, what I will have left with the equation is this thing. So this thing over here is this one, while this thing over here is this one. This is your definite integral. Alright, and I can simply solve for my definite integral for if I were to sub in my c over here as this one, I'll have c squared over 2. If I sub in a over here to this, I have minus a squared over 2, this whole thing. Alright, plus, multiply with your this stuff over there, okay? And then plus, I keep this one over here, evaluate this integral. So I sub in from a over here first, so what I have is a cubed over 3, and then sub in this 0 to here is 0 divided by any 0 is still 0, so it's like this, okay? Then I could factorize out this half over and half over here. What I will have is, okay, so when you factorize out half, you can cancel with your 2 over here. Then I can also factorize over my 3 towards this side, so I have 2 over 3. Alright, therefore this is the understanding over here now, your moment. Okay, and further simplify this system, alright, as EA, alright, over R, A square B. So I'll just simply take out one of the A over here, so it becomes A square, and the A will multiply inside EA. Okay, so the purpose of this is to let this becomes your beam theory system, while instead of EY over R is now EA. So this thing over here is somewhat like your Y now. Alright, so when you talk about this in such of a manner, you can re-represent this whole thing as your U strength, because if this reaches your U strength, things will start to U, right? So therefore, for example, if this point reaches your U strength, it will actually start to become like this, and eventually it will become like this. So for example, if you were to continue to U, right, you have more of this thing over here instead of this shape. Maybe a hole on that. So if you were to increase your stress over here, then you can somewhat increase in this region, and soon it will become like this. Okay, so this equation somewhat represents the outcome, right? But I don't know the meaning behind how this works. I'll just take it first. Alright, so I didn't actually touch the rest. These things are all the same, just that I rearrange this thing into here, and then I change this as y. Okay, but it's because it's going in this direction, this thing is going in this direction as you starts to yield. If you just take a look, if it starts to yield, further yielding will continue, and eventually the line will be something like this. Your angle over here is somewhat getting smaller and smaller, and eventually it becomes like this. Alright, so therefore it should be like this lah, okay? But therefore you can see that the trend is that you're going in this direction. Now this particular line is moving and moving and moving all the way like this. So you bring your square over here upwards and upwards and upwards all the way up till everything is like that. Alright, so therefore it's moving in this direction. So your U stress is equals to your EA over R minus, because we are moving in this direction, negative. Alright, this part is positive. Sorry, this thing is positive. Right, so we can rearrange this one as minus sy is equals to EA over R. So we know if E over R is this, we just simply sub in as minus sy. So what we have is this thing over here. Alright, so simply changing this to minus sy. Alright, your U strength. Okay, so let's continue. Therefore, if we were to multiply this in, alright, what I will have is this one times this one is over here, multiplied by your C square, and then this thing over here multiplied by your A square. Alright, I'm just simply doing that. And then over here, I'll just simply bring this B to this side only. So I have B A square instead of A square B. Because as you can see, we are now in terms of the BA square, and the sigma the U strength itself. So this portion over here, I can actually somewhat rearrange them and minus them each other. In order to do the last step, then I realized we need some cheat code. Alright, if you were to take a look in your notes, alright, from this point over here, let's take a look. Alright, if you were to, you can actually change the sign. So from minus, you can factorize out this minus over here, and what you have is minus, so therefore it's somewhat minus SYB/2 C square plus A square, some sort. So therefore this whole thing become plus. Alright, so this is something, that's what they're doing. Alright, therefore goes all the way back to your equation, your general equation we have first derived, or which is this one. Alright, that we should sub in this thing as minus. Alright, it's because your U strength at the top part over here is negative. Alright, I have no reason why it's negative, but it's negative. Okay, so be careful, and which is actually deflected over here. For the integral from A to C, it's negative your U strength. Alright, so this is something that you need to take note of. Alright, so if this is negative, all of this that we have been doing all along, it's all negative. Alright, it may be the reason of that. If you're talking about this thing over here, as you bend, alright, you're gonna start to go in this direction. Alright, so this direction is negative sigma y. Alright, and then, or your U strength. Alright, or if you're going upwards, is positive U strength. Alright, and as long as you go by all along, then you have a larger negative SY. Things like that. Alright, I think this may be the case. Alright, but still for the moment itself, I believe that it still holds for the negative sign. Alright, for the EY over R, or the EA over R, if you have to say in that manner. Alright, so these are the things that you may need to really take note of. These are the little stuff. Alright, and therefore our negative over here will propagate all the way down. As you can see, all the negative. Alright, so all the negative, everything all is over here, up till the last stage that we are. Then we do something, then we see the stun. Alright, but anyway, you can multiply the negative now. So if the multiplying is negative times negative, or if I were to factorize out, how do I say? Okay, I should factorize out this negative, will be better. Alright, so I have positive over here. Okay, then I can still multiply inside. So minus y times c square, I have minus ybc square. Then minus syb times minus a square, I have a plus a square now. Okay, so you can see that there is so many u times b, u stress times b, u stress times b. I just factorize out all the u stress times b. So what I have is this over here. Okay, and then you can just take a look. I just factorize them up and then rearrange. I bring this c square, this minus c square. Alright, I bring this all over here, and then this left over is a square. I just bring it over here, and then this minus 2, 3, I just bring it over here, and minus 2, 3 times a square. Alright, so the SYB are all factorized out over here, just to show you. And then we can do with this. Alright, so what if this actually 1/3 a square, right? It's because this is somewhat 3, 3, you have to say it like this. Alright, so therefore I have 1/3 a square now. So I can simply rewrite again, equals to your moment. Ta-da! And then at first, before you yield, or you have minus a, 0, and c. After which, when you yield, you somewhat have this form over here, where you say that this is c, a, minus a to minus c, this is the 0. Alright, so when your a is equals to c, alright, this means that you start to yield a little bit. Alright, so when you start to yield a little bit, you can simply sub in a is equals to c. Alright, where at this particular point over here. So when I sub in a is equals to c now, what I have is 1/3 c square minus c square. I'll have minus 2/3 c square. Multiply with your SYB, what you have is your U strength times your B. This is the 2/3 over here. Alright, c square. Okay, the absolute value, because we just want to get the magnitude of the moment itself. so you don't care whether is it negative or positive. So therefore, your moment when your A is equals to C, when it starts to yield, right at this point over here, is this equation. Alright, and therefore it's also shown in your over here. Alright, this is maybe I should crop this out. Hold on. Yeah. So this is tilted. This is sy. This is b. This is c square. Alright, same as this thing. Alright, taking note that we're taking absolute values of things. Okay. For this somewhat answer your answer for pure bending yielding will initiate certain moment like this. Alright. So what if the plastic collapse? Alright, if the plastic collapse, what does this mean is that for example, if you further bend your stuff, if you further bend your beam, you eventually reach a point where A reaches 0. Alright, where A is equals to 0 because it's at the neutral axis. So far so good. And please take note that we're not talking about x-axis or y-axis. We're not talking about all this. Alright. Therefore, we just simply substitute whenever A comes lies. Alright. If A equals to 0, this means that the plastic has already collapsed. If the A is equals to C, this means that you are still yielding, but your plastic haven't collapsed yet. It's still somewhere safe. I mean, although not very safe, but at least you haven't collapsed yet. Right, when you don't see any A, this means that you're always linear. Alright, this is minus A, so yeah, at least you know what I mean lah, okay? Therefore, instead of saying that A square is equals to, A is equals to C, now we can simply move this away because we're not talking about this scenario anymore. So I'll just bring this down. Now, let's continue with this equation. So I will highly assume that, I highly suggest that you take down this formula. At least this is something that you need to know. Alright. And that if A is equals to 0, then this whole thing becomes 0, and therefore you have SYB minus C square. Alright, or you can take an absolute value. We're talking about the yield strength times your breadth of your stuff, C square, M equals to B. And if you take a look, and your plastic collapse, it will not occur until the moment is this. So you have to crop it out, this thing over here. So this is your SY times B C square. Okay, so far so good. So therefore these are the little stuff that I just want to convey to you, and although this is a very long video. Next video we'll just do a quick summary of what we have done and what are the important points along our pathway. So at least when you in the future when you do things, you'll know at least it's something not very tough to do. Alright, I shall see you there.